Hello everyone, welcome back to my channel. In this video, we'll be discussing in detail about how to interface a 16x2 LCD with STM32. So without any further delay, let's move ahead. So this type of 16x2 LCD you might have seen in many places like during your major projects, minor projects or in your hobby projects. So every 16x2 LCD will have 16 pins. So you can see they are numbered from 1 to 16. So last two pins A and K will be using them to control the brightness of the LCD. That is, we'll be connecting a potentiometer here. You can use a potentiometer, and by adjusting the value of the resistance between A and K, the brightness of the LCD varies. And this VSS you can connect it to ground, and this VDD you can give it to 5 volts. And coming to this RS, RW and E, RS is known as register select. What is register select and what is enable, we'll see in the further part of this video. And from D0 to D7, these are the data lines on which you can keep your data or command based on your requirement. So coming to the description of each pin, so VSS will be connecting to 0 volts and VDD will be connecting to 5 volts, and VO you can just leave it. And coming to RS is known as register select. So you'll pull it high if the data you're keeping on the lines is data, or you'll pull it low if the data or the uh, information you're putting on the data line is instruction. That is, for example, if I am sending an instruction to LCD 0x36. So if 0x36 is an instruction, like if I want the LCD to understand that 0x36 is an instruction, I'll pull the register select line to low. So that means that when register select is pulled low, LCD will understand, acha, the data I'm getting is command, and it will have a proper lookup table kind of thing, where in which it has different tasks to do based on the command we are giving. And coming to read write, so to write onto the LCD you have to ground it. If you want to read from the LCD, you have to pull it to the high, like you have to pull it high. And coming to enable pin, this enable pin you will be changing between high and low based on the data write cycles or command write cycles. And from db0 to db7, these are the data lines. So whenever you're keeping you want to send data or command to the LCD, these are the lines to which you have to write your data. So like what I mean you have to write is, for example, if I want to send something like 127. So if I want to send something called 127, so what I'll do is, so here db7 will be the MSB and db0 will be the LSB. So if I want to send 127, I'll keep all ones here and 0 here. So this will read to 127. So in this manner, whatever the command or data I want to send, I have to write those command or data first onto the data lines of the LCD. And moving further, steps to send a command or data to LCDs. This is a timing diagram. If you want, you can look into it. Each corresponds to each signal. And coming to how we are doing it is, first we have to load the command or data onto the lines db0 to db7. Loading is nothing but, for example, if you have connected these db0 to db7 to port A0 to port A7 pins, then you can simply write GPIO A arrow ODR or with your data, let's say CH. So this will simply write whatever the data you want to keep on the data lines onto the data lines. So this is just an example if you are using GPIO A. And coming to next step, once you have kept the data, you have to properly configure the register select pin. So if you are sending command, you have to pull it low. If you are sending data, you have to pull it high. Once you have configured the register select properly, you have to send a pulse. So if you can see here he is sending a pulse on the enable pin, saying that I have kept the data or command, so process accordingly. So the pulse width can be from 5 to 6 milliseconds. So the timing diagram, like you might have understood, you have to keep the data on the data lines and then configure the RS and then send a pulse on enable pin. And coming to steps to initialize LCD, before what we have seen is how to send a command or data to the LCD. Now we'll be seeing how to properly set the LED. So first we will set the LCD to 5x8 mode. What is 5x8 is? So if you move to the previous slide, so if this is an LCD, you'll have something like you'll have 16 columns. So this is how the LCD actually looks. So if you consider this one cell in a magnified manner, what you will see is, so this is what you have. What are the character you will be displaying? Those character will be formed by joining either of the dots. So 5 rows into 8 columns. So this is how it looks. So what will be the first command of initializing the is setting the LCD to 5 cross 8 mode. That is, you are telling the LCD that we are operating in 5 columns and 8 rows mode, and then you will be sending a command asking the LCD to display the cursor so that user will be knowing where the cursor is pointing. And next we will be setting the cursor to auto increment mode. What do you mean by auto increment mode is whenever you are sending data, for example, if I want to print hello, whenever I send the first character H, the cursor will be pointing here. Now, if I am not auto incrementing the cursor, when I send the value E, that H will be overwritten with E. This is not what is intended. So what we do is whenever I write H and whenever I'm sending E, I'm expecting the cursor will go here and write E here. So this is what I'm expecting. So we have to set the cursor to auto increment mode. Then we'll be clearing display. To clear display, there is a certain command known as 0x01 that we'll be seeing in the further slides wherein which have command set. And next we have the register value. That is in the previous slide what I have shown. This particular cell has an address known as 0x80 and this particular cell has an address known as 0xC0. So if you want the cursor to move to a particular location, you have to tell it the address of the particular cell. So I want the cursor to start here, so I'll be sending a command called 0x80. So further we will be seeing how to enable clock. As I mentioned in the previous videos, how to enable clock is like you will be using RCC AHB1 ENR. If you have not seen my previous videos, you can see part 2 of this series, where in which I have clearly explained how to write some data into a register or how to enable clock. Why is the reason we are choosing RCC particularly or AHB1 ENR particularly? And in that video, I have also clearly explained how to go through the reference sheet of STM32 F401 RET microcontroller also. So for this video, we will be using GPIO A, that is only port A for all the operations. So I'm enabling only port A. So if you keep 1 here, the hex code will be 0x01. That is what I'm putting there. And then this is the model register, GPIO model register. If you want, you can take a look because I'm not going to explain in detail how to put values into model register. And as I mentioned earlier, how to write a value into a register, we'll always be using and equal to negation of combination and is equals or equal to combination. And equal to negation we'll be using to reset particular bits whichever we are intending to, and or equal to we'll be using to set particular bits. So now our objective is, as I mentioned earlier, we'll be using complete port A only. So the schematic that we'll be following for this video is, so we'll be connecting all the data pins from PA8 to PA15, and register select and enable we will be connecting to PA0 and PA1, and read write bar I am directly grounding it because we'll only be dealing with writing into the LCD. For now we are not interested in reading from the LCD, so I am directly grounding R by W. And you can see RS I am connecting to PA.0, enable I am connecting to PA.1. All the data lines are directly connected from PA8 to PA15. So now our objective will be, we have to make PA0, PA1 and from PA8 to PA15 as outputs. So if you go through the model register of port A, what you will see is, so what we are intending, we need PA8 to PA15. So all these pins, we need them as outputs. And PA0 and PA1, we need them as outputs again. So before configuring them as output, if you are properly following the series, I mentioned whenever you want to configure a register, first you have to reset it. So the reset state of this register is 0 0. To bring them into reset state, we'll be using and equal to negation of combination and put all the pins we are intending to make them 0 as 1. So if you keep all these as ones, so 1 1 1 1 and 1 1 1 1 1 1 1 1. So you'll get 4 Fs and here you'll get an F. So that is what we will be doing. We will be yeah, see, you can see we will be using and equal to negation of combination with 4F and single F, because you can see here we have 1F, 2, 3, 4F and 5F. So once you are done with resetting the register, next you have to program it as output. So for output, 0 1 is the combination we are intending. If you combine 4 bits together, like 0 1 0 1, that is 2 pins if you want to program as output, this will give you an hexadecimal equivalent of 5. So here we have 4 pins, sorry, 8 pins, so we have 4 5s, and here we have 2 pins, so we have 1 5. Like this is a simple shortcut. Like if you want consecutive pins to be as outputs, you group two pins together. For example, if I want 4 consecutive pins to be output, you group them 2 you will get 2. So in your GPIO motor register, corresponding positions will be 5 5, because 0 1 0 1 0 1 0 1. So this will give you 5 and this will give you 5. Yeah, this is what we are intending. PA0 PA1 as output, PA8 to PA15 as output. And this is a more ODR register configuration, where in which you have 16 bits each corresponding to their respective pin. And these are some of the common command codes that we'll be using to address 16 cross 2 LCD. The important ones are 0x01 for clearing the display, and auto increment mode 0x06. And if you are a fan of blinking cursor, you can use 0x0f, or you can simply adjust with 0x0e, where in which cursor is just displayed. And apart from this, this is the most important part, 0x38, which will tell the LCD that we are operating in two lines, 5 cross 7 matrix. Sorry for the wrong information. In the previous slide, I mentioned it as 5 cross 8. It is just a 5 cross 7 matrix. And coming to developing LCD driver functions, as I mentioned earlier, we will be like we have to send data to the LCD in a particular format. Like in the steps to send, I have said that we have to keep the data and then enable the register select, and then we have to send a pulse on enable pin. So for doing all this, if you want to send data multiple times, performing the same operation multiple times is useless. So for that, we will be writing LCD driver functions, which will majorly contain two main compulsory functions, which is LCD print and send command. LCD print will send data onto the LCD. LCD command, send command will send command to the LCD. And coming to LCD init, it is just a combination of instructions that is used to initialize the LCD. And print str, this is a optional function. If you wish, you need it, you can use it, or else you can avoid it. So coming to LCD print, what we'll do in this is, first we will left shift the data by 8 bits, because if you observe the schematic, we have connected LCD data lines to upper 8 bits of the port. So if you are performing a simple OR operation with the port, it will write the data into the lower 8 bits. So to avoid that, what we have done is we have connected the lines to upper 8 bits. So we have to left shift the data by 8 bits, so that the data is completely to the upper byte only, and then load the data. Loading the data is nothing but performing OR operation with the particular uh, output data register, and then make register select as high to say it is data, and send a pulse on enable pin. So this pulse width is of let's say 5 milliseconds or 6 milliseconds. And in send command ch, the same thing is performed. The only difference you see is, here you make the register select as high to say it as data. Here you will make the register select low to say it as command. So these are the two main functions, LCD print and send command. Now coming to the third important function, LCD init. So this will contain the series of commands that are used to initialize the LCD. So those commands are 0x38. This is the first command that you will be sending, because first you have to tell the LCD that we are operating in 5 cross 7 matrix with two lines. So, and next you will send 0x0f to turn on the display and blink the cursor, and 0x06 as mentioned in the previous slide to auto increment the cursor, and 0x01 finally to clear the display. If you wish, you can also send 0x80, which is the address of the first cell of the 16 cross 2 LCD, or else it's fine. It will start with that cell only anyway. And coming to the print str, what you'll do is, like here it's fine. We are just displaying one character. What if I want to display a string like tech talks? So if I want to display a string like tech talks, I'll use this function print str, in which the function will take care of looping through the string and sending character by character onto the LCD using LCD print function. So like, if you want, you can pause here and take a look at how the algorithm is designed. And then we have the driver function codes. As I mentioned earlier, here we have the first we have the LCD print, where in which first we are clearing the ODR pins. This is most important. Why we are doing this is, for example, if you see here, ODR is of 16 bits. Each hexadecimal symbol will represent 4 bits. So here we have 16 bits. What we are doing, we are making first 8 bits as ones, and making a and equal to OR operation. What does this mean is, so you're initially keeping the ODR value of first 8 bits as 00000000, so that whatever the data you will be performing an OR operation with the particular pins, the data will be properly written. And after 8 bits, you have another 8 bits. Among those 8 bits, you are only considered about 2 bits, which are first 2 bits RS and EN. So you will not consider the remaining 6 bits, and you are concerned about only last 2 bits. So you have to flip all this in order to get this data. So if you flip this, you will get 11111111. This you can keep this as zeros only, and you will get 11. So these 11s will lead to FF, and here double one will lead to 3. So this is what we have, FF03. And coming to the next part, we are left shifting the data by 8 bits. The explanation is already provided previously. And once you have left shifted the data, we are making register select high to tell that the value I am sending is data, not a command. And once you have made the register select high, we are making the enable high. As I mentioned earlier, or equal to combination we will be particularly using in order to set something. So making enable high. 0x02 means 10. If you write here, this will corresponding to hexadecimal equivalent to this 1 will corresponding to enable pin. So once you are done with making the enable pin high, you will wait for 5 milliseconds, and after that you will be using and equal to negation of combination to reset the enable pin. So that is, if you see here, you are making it high, waiting for 5 milliseconds, and then you are making it low. This is the pulse that the LCD is expecting to understand that data or command is placed on the lines. And then coming to the send command function, the same replica, just the only difference is here we are making the register select as high, but here we'll make the register select as low. For that, here register select we are using it as or equal to combination. Here, in order to reset the register select pin, we will be using and equal to negation of combination. Remaining all principles are same between these two functions. And coming to LCD init, as we already defined the send command function, we'll directly sending the commands using the send command function one by one, like 0x38 for 16 cross 2 and 5 cross 7 matrix, and 0x0f for cursor blinking and display on, and 0x06 for auto incrementing the display, and 0x01 for clearing the display. And coming to the print string function, as I mentioned earlier, it will loop through the string until the \0, which means the string terminator comes. It will send data character by character onto the display using the LCD print function. So this is all we have about the driver function. Now if you observe the final code, the only change you have is in the main function. In main function, you will be take care of initializing clock for the particular port, and then you will obviously configure the motor registers of that port for output pins as PA8 to PA15, and then PA0 and PA1. And you will call the LCD init function, because before performing any operation you have to initialize the LCD first. And once you have initialized the LCD, you will be sending a command called 0x80, so that the cursor will be resetting into the home position. And then you will be printing some data, like I am printing here welcome to, and changing the location to 0xC0. If you observe here, 0xC0 will make the cursor to shift from the first line to second line, and in the second line I am printing tech talks. So this is all about the whole code. If you wish, you can pause here and see the code, or even I am providing the GitHub repository link in my description, which has all the details about the code and even the PPT I'm sharing here. This also you can access through my Git repository. And now we will see how the Keil we'll go to the Keil Microvision IDE, and then we'll see the code, and then we'll see the Proteus simulation also. So this is the LCD driver code. We have MS delay function and all the remaining driver functions, and we have also main function. Once you have done all this, you have to translate it and then build it, and then you will be going to Flash, configure Flash tools, and once the you will get a pop-up wherein which you have to go to debug. Here you have to click on use simulator and then go to output. You have to ensure that the create hex file is checked, and name of the executable you can keep any name. Here I'm keeping lcd underscore driver, and you can click OK, and then you can click on build. Once you are done with it, you can move to the Proteus folder. Here I have already drawn the schematic for, but you have to draw the schematic. I have used bus and logically connected this data lines and then reset and enable, register, select and enable. You have to double click on the microcontroller and choose the proper hex file. Now I am choosing the hex file that I have built. So I have loaded my hex file. You can see lcd driver.hex, and then I'll click on simulate button. So you can see I'm getting welcome to Tech Talks because this is what I have programmed it to write. So this is all about interfacing a LCD with STM32. In next video, we'll be seeing how to interface keypad and LCD together with STM32. If you find this video informative, please do share this video with your friends and like the video. If you have any further doubts, please let me know them in the comments. And please subscribe to my channel Tech Talks. Thank you.